Alright guys, so if you finish this, you are done with your test. Wherever you are on lesson 9.1b, we're actually going to start on question 4. So I know on some of the periods we were finishing up on 3 and not everyone finished. So I would like you to finish up on that part first, and then let's go ahead and jump right into number 4. So the first question, it says, when a line association is considered strong, draw an example. So remember, we have a few types of associations. When it's strong, you see a very nice association, a nice correlation between them. So when you look at these, you can say, oh yes, the values are all going up at the same time. Or, if it's all going down, something like this, this would also be considered a strong correlation because you have all of these points clustered really close together. So it says, draw an example. These are two examples of a linear association considered strong. In red, I'll draw this. Don't draw it, but I just want to give you an example. This would be more of a weak association. Similar to the rebounds and assists, if you see these points, they're kind of spread out, and I probably drew a few too many. So let me go ahead and delete a couple of these points that really show you what it would look like. So this would be more of a weak association. So you can see they're kind of going in a general upward way, but it's not as strong. The points aren't as tight as the blue ones are here. So that's what a strong association would be. So when is a linear association considered weak? So go ahead and write this down. It is considered weak when the points are not close together. I should say cluster, that's just a group of points. So when the cluster is not packed together. Or close. We kind of give an example of that, so I'm going to go ahead and draw this again. I do want you to draw this one. So when we have a bunch of points, they're going in the same direction, but the points aren't as clear as the other ones were. So it looks something like this, where you could see there's a general trend going upwards here, but at the same time the points aren't really compacted. So we would have it's a weak association, it's a weak correlation where the points are compacted together. So when is a linear association considered perfect? Draw an example. A linear association that would be considered perfect would be a perfectly straight line. So an example here, don't draw this line just yet. It would be when all the points land right on this line. So if it has like a constant rate of change, that association would be considered perfect. Now if I move this line, you can actually see that the points would make this type of line, and that would be considered perfect. So I'll go ahead and write that down. Make sure you write it down with me. When all points are on the same line. All right. So it says directions. Describe the association between x and y using the terms from the previous page. So we're looking for strong, weak, and perfect association. So right here, it's going in a downwards way. It's not really in a straight line. It's kind of going down like this, and then curves. So this would be a nonlinear association. I would call this, it looks pretty consistent. They're coming down and it curves like this, so I would call it a strong nonlinear association. Strong and nonlinear. Alright, now looking at this one, if I drew my line, it would hit every single one of those. This one would be a perfect see exactly the word they want us to use. That would be considered a perfect linear association. So you can see the line hits every single one of those points. Alright. Now this one, it looks like it's going in an upward direction. You can see that the points are going upwards. They're all pretty much close to this, so I would call this a strong association. And it's also a strong positive association. Positive should have gone right in there. So what I mean by that is when my x values are increasing, my y values are always increasing as well. That would be a positive, strong association. Now this one, I would consider this one no association. People might want to justify, well, say it's kind of going upwards, but not really. If it is, it would be extremely, extremely weak, but I would go and just say this is a no association would be the safest bet. So you can't really tell whether a correlation is going on here or not. Now this one, it has two nice clusters of points. It has them right here. It has them right here. And you can see that these are going in a general upward area going this direction. So I would call this a weak to moderate positive association. And you can see it's going in this upward direction this way. First, so we got a cluster of points right here. You can see that they're kind of going in a downward direction. So having my best fit line, it would look something like this. And it's basically just the general direction that all the points are going. And we have some points like this that are somewhat outliers, but generally they're all going down in a downward direction. So we'd call this a moderate negative association. This means as my x values are increasing, my y values are decreasing, and vice versa. So what I want you to do is examine the following scatter plots and describe the association between the two variables. Circle any clusters in the data, put a star on any points that appear to be outliers, use the context of the given problem context to give a possible explanation on why those trends, patterns, or associations exist. So, let's go ahead now and look at this. So it says, the scatter plot given below shows the temperature of a cup of tea sitting on the countertop for 30 minutes. The cup of tea is sitting in a room that is 70 degrees. So we looked at one like this before, and the key part of here is there an association? Is there something going on? And in fact, there is. So when we look at this, we see that it's a nonlinear association. It's definitely not a straight line. I can't make any straight lines here. So that's the first thing. It's nonlinear. And it's clear that it is following a pattern. So what I would say is start the initial temperature. So the tea was initially 180 degrees when it was initially poured, but then the temperature decreased rapidly. You can see it's going down. It's being measured every few minutes, and the temperature is going down fast. So then, as it's getting closer and closer to room temperature, which is 70 degrees, the tea begins to cool off a little slower. So T begins to cool off slower. And then the temperature continues to decrease until it hits 70 degrees. Until the temperature of T is 70 degrees. And you can see about like right here is a 70 degree mark, and this is where it cools off to. So that's the story. So really quickly, nonlinear, it cools off until really fastly at first, and then it cools off slower until it hits 70 degrees. Alright, so let's go ahead and look at this one. It says Paradise Pool records the average daily temperature and the number of visitors in their pool for 18 days throughout the month of July. On July 24th, they celebrate Pioneers Day, and admission is half off. The average daily temperature is 90 degrees. So if we look at the average daily temperature, and this is through the entire month of July, we're talking about people going in a pool and temperature. So if you think about it, the warmer the temperature, the more people that are going to be in there, and the cooler the temperature, the less people that are going to be in there. So as we can see, this shows a positive linear association. You can see that the graph, the points are generally going in an upward position, which means when temperature increases, visitors also increase. So we would start by saying this has a positive linear association. Now I want you to write down a story. And it says, as the average daily temperature increases, the number of visitors also increase. That makes sense, right? So, as temperature increases, so does visitors. And then it appears that many of the data point clusters are between 80 and 90 degrees. So if you look at this, here's 80 degrees in temperature and 90 degrees in temperature. If you want to throw in 100, that works too, between 80 and 100 degrees. And that's where the majority of the people are going. So it seems like the most people are, that's when the most temperatures were going on. So it says, it appears that many of the data point clusters are between 80 and 90 degrees and 200 and 300 visitors. Which suggests that the pool regularly has between 200 and 300 people that typically visit the pool at that temperature range. So what this is saying is in this area, let me erase some of this. That says in the month of July, the majority of the people, the majority of the days are between 80 and 90 degrees, and between 200 and 300 people go. So it's this section right here is what they're talking about. So we can write that. Most days temperature was between 80 and 90 degrees with 200 to 300 people going. Alright, there appears to be an outlier. I would say when there was 90 degrees, we had over 600 people come. So we're going to put a star right there, and that was probably on July 24th when temperature was half off. So on that day, admission was half off, and it was also a holiday. That would explain why there's so many visitors. So also, the point 8550 appears to be an outlier as well. So if we go to 8550, this was an outlier. It's pretty warm, but not a lot of people. So maybe the pool was closed early for cleaning. Maybe there's a big event in town, but there's some reason why there was not a lot of people.